Welcome back to another episode of Steel Connections. We're your hosts, Brandy Martin and Sean Chuber, and today we have an exciting topic to talk to you about. Sean, should we just kind of give them our listeners a brief about, how we met our guest today and the things that he talked about and what excited us about having him on today?
I think we should. Without giving him away initially, we were fortunate enough to attend a conference for the Pacific Northwest Steel Fabricators Association. So shout out to them. And it was in Coeur d'Alene, Idaho this year. They had many very educated speakers and many who are just intriguing for sure. But
High
this one
caliber.
particular, yeah, high caliber folks. This one for sure definitely caught our attention, though. He is a fantastic, I guess maybe fantastic's not the word. He's more of an expert in steel structures, steel design, and the meaning behind using steel versus maybe concrete or mass timber. And we're really excited to have someone of his level on our show. So this is
Yep.
a great opportunity for us.
No, and I loved today's guest is Scott Melnick. He is a senior vice president at the American Institute of Steel Construction. And what I loved about hearing Scott talk at that conference is just the way that he was able to take this kind of very thick and meaty topic about sustainability in this, steel construction industry, and just really simplify it and make it easy to understand. And it was very sensible, the things that he was talking about. So I just was really excited about trying to gather him and get him on board here. Scott is not only the senior vice president at AISC, but he's also contributed to the industry in a number of ways, including leading the NASCC, the Steel Conference. And he also supervises AISC's communications, their market development, government affairs, sustainability, IT, university relations, continuing education. And I think I captured it all, but just a ton of things. I was just floored by the amount of things that he is managing. And if that's not impressive enough, he holds a bachelor's and a master's degree in journalism. Makes sense why he's a great storyteller. And he was the former chief editor of Modern Steel Construction, the former editor-in-chief of Commercial Renovation magazine, and was a senior editor at Building Design and Construction magazine.
That is an impressive resume.
Yeah, no, right? Our guests are going to love hearing from him today. It made me feel bad about myself, like I was not doing enough when I was researching this. So anyway, Scott, let's go ahead and have you come on out.
Good afternoon. Thanks for having me on.
Hey, Scott.
It's great to be here and see you both again.
That's a pleasure.
Well, glad to have you here. To get started, Scott, do you want to tell our listeners who might not be familiar with AISC a little bit about the organization and how you contribute to the industry?
So AISC is a different group than a lot of others in that we're both a trade organization and a technical institute. So as a technical institute, we actually write the specification to which all steel buildings in the United States are built. And so our engineering and research department produces the Manual of Steel Construction, which is a 3,000-page explanation for engineers on how to design in steel. We produce 36 design guides. And so we produce a whole myriad of technical information. But we were founded back in 1921 to bring uniformity to the industry. And so we were founded with the purpose of promoting the use of domestically fabricated structural steel. And what happened back then, steel was very dominant material. Really, you couldn't really build much without steel. But we were actually losing market share. And one of the reasons we were losing market share is because back then, every steel mill was producing different shapes, and every construction project was being built to a different standard. So if you could imagine that, you get a job, and you're going to order steel from one of the mills, and it's not the same steel you would order from the mill down the street. It's a nightmare. So we brought standardization to the industry. And we've been doing that since 1921 for more than 100 years now. And a lot of what we do, though, is also promote the use of steel. So we have a lot of marketing people. We have publications. Our conference has about 6,000 attendees. We also do a lot of continuing education. We educate about 10,000 engineers and architects every year. And we also work with students. So we're inside of about 250 universities on an annual basis.
Wow.
That is incredible. And I think,
Yeah.
to me, I think the resources and training is, the education and training is just a huge value add of being for us being a member of AISC.
Mhm.
I appreciate all you do with that. Diving into like our topic today about sustainability, Scott, you had a really interesting perspective about how steel is contributing to sustainability and the impact on the environment, reducing emissions. Can you tell us a little bit about that?
Yeah. Sustainability is such a broad subject, and there's so many misunderstandings about sustainability and about structural materials. And usually when you talk about sustainability, what all the media talks about is wood and mass timber. And they forget there's other materials. And I can understand them ignoring concrete, but there's a lot of misunderstandings about steel. And perhaps the biggest misunderstanding that we hear is when we talk about steel and we talk about American steel, we sometimes get people say, they make steel in America? And we say, yeah, we make about 6 million tons of structural steel. We make about 6 million tons of wide flange every year in the United States, which is about how much we consume as well. And everyone's surprised to hear that. And then the second thing they hear, if you remember when the former chairman of Microsoft, Bill Gates, was talking a lot about sustainability issues, and he was talking about the need for green steel. And when he was talking about green steel, we were all kind of chuckling about it, because one of the big things he talked about was the way we can reduce carbon emissions with steel is to move from a basic oxygen furnace to an electric arc furnace. Now, for those of you who don't know what I'm talking about, because those are just letters and words, in traditional steel making, what you do is you take iron ore and you take coke, which is a processed coal product, and you superheat it, and you add a bunch of other stuff, and you make steel out of that in what's called a blast furnace. So it's very, very energy intensive, and it's very, very raw material intensive. And the production of coke, and not the good coke, we're talking about the coke we use for steel making.
Although it looks the same, doesn't it look the same though?
Well, maybe. I'm not saying, and you don't want to mix them up. I'm telling you that.
I'm sure.
So you're dealing with that. It isn't a great process for the environment all the time. It's getting better, but it's still pretty carbon intensive. And what he talks about is the need to move to electric arc furnaces. And what electric arc furnaces do is they replace coke and coal with electricity. And if you can get renewable electricity, if you're getting your electricity from windmills and solar, nuclear, anything you're getting that's renewable, suddenly the carbon in your steel is going to go down drastically. And what's interesting is in the US, for structural steel, for beams and columns, for wide flange, we moved back in the 80s, in the 70s and 80s, completely to EAF. So we produce those 6 million tons. Every piece of wide flange, what most people would think of as an I-beam, every single piece produced in the United States comes from an electric arc furnace. But it also gets even better, because we really talk about a circular economy. And what we're doing with steel in the United States is we're not taking iron ore. What we're taking is scrap. We're taking your old cars, we're taking refrigerators, basically anything that'll take a magnet, anything that's ferrous that way, we're dumping in a kettle. We're shredding it and dumping it in a kettle. We bring 2 electrodes down, you get arcing between it, and we melt it. So if you look at a beam used in a building in the United States today, I can assure you it's probably domestically made to begin with, because somewhere between 92 and 94% of all the wide flange used in the United States is produced in the United States. And I can also tell you that at a minimum, it's 93% recycled content, because the mills today are using between 93 at the low end up to 98% at the high end. So
That's
we're
incredible.
100% recyclable, and we're producing with renewable energy. And what's really cool, as we're moving the grid to becoming more and more sustainable, we're not that far from 100% renewable energy. If we hit 100% renewable energy, we'll reduce the embodied carbon in steel by 41%.
Wow.
And the reason we keep talking about domestic is if you compare typical steel products from the US versus typical steel products from, say, China, they're about 2.5 to 3 times higher in embodied carbon than we are.
That's interesting because Brandy and I were at a conference yesterday for wind and wave energy, right? And one of the topics of conversation was particularly around steel production. And I think that there may be a major misconception on how that's actually produced, because they still are under the impression that it's not produced with electricity, that it's still under some kind of gas or coal furnace. And their suggestion was that we move from the coal or gas heating, however they do it, or did it back when you said way back when, to
or if you're in China, how they do it today. Mm-hmm.
Yeah, how they do it today. Exactly. I think there's a major misconception on where steel is at currently and where it's been for quite some time. And I don't think that is common knowledge at all.
Sure.
I would agree with that if I might. In fact, what they were saying is they're waiting for this green steel production ability to take place, and that hydrogen just isn't there yet. And I was so confused because hearing you talk about this topic, it's like, well, why are we waiting for this at all? It's already green.
So worldwide, about 70% of all the steel produced worldwide comes from a basic oxygen furnace, the old way, and about 30% comes from electric arc furnace. That's worldwide. But in the United States, about 70% of our steel of all types comes from electric arc furnaces, and about 30% is from BOF, basic oxygen furnaces. And if you're looking at beams and columns, if you're looking at wide flange shapes, it's 100% from the AF already.
Which is the main structure of everything, basically.
Right. So again, we're talking about buildings and bridges. We're not talking about cans and
of course,
refrigerators.
Yeah.
Although once you make your refrigerator, if you're making it from a basic oxygen furnace, we're still going to take that scrap and remake it into beams and columns in the future.
You would think as much as a new refrigerator costs, it might as well be made out of Panda. Where are they expensive now?
Yeah, it's fascinating. The whole field of sustainability. Like I said, there's so many weird things you hear. I was reading an article earlier this week, and it was from the wood industry, and they're building I think they're talking about building a 26-story wood building.
I've heard that.
Yeah, they're not doing it, but they're talking about doing it. This is a different one, and they were comparing it to it's a residential building, and they were comparing it to a concrete building, and they said that the concrete building they were going to save $30 million by switching to wood, and they were going to convert. They were going from 100 million down to about 70 million. And I was thinking, wow, that's pretty darn impressive. I'm kind of, if I was a developer, I'd be really excited. And I'm reading on about it, and I was curious how they're getting that savings, because typically wood construction, especially as you go to high rises, gets more and more expensive. And I was curious how they were getting that. And what they finally described is they were getting the reduction in cost because they did some very sophisticated engineering on the project, and they managed to increase the spans, and they increased the spans from a 10 by 10 grid to a 12.5 by 15 foot grid. And that's where their $30 million in savings came from. And I'm thinking, I've never seen a concrete building with 10 by 10 grid. Normally, we're talking 15 by 24 or something of that nature. And so what they've actually done is they've taken a terrible wood design and said, if we did it out of concrete with that terrible design, it would be really expensive. I heard another. I was actually listening to a different podcast, not your podcast. It was a different podcast today, and it was a very respectable architectural firm who's partnered with one of the leading engineering firms, and they're talking about how you would design a 600-foot tall wood building, and they were talking about all these things they could do, and they said, "Yeah, we're having a little bit of trouble because the first 10 stories are solid."
So that's a solid base. Is that what
It's a
you're
solid
Wow.
10-story high base of wood in order to support it. And I'm thinking, this is really not practical.
saying? What a waste of space. Yeah, I agree.
Well, how long would that burn for if it caught fire? Holy cow.
That's exactly what was going through my head.
Well, but we all know wood doesn't burn, right? It's what the wood industry tells us. My seminary as a Boy Scout fully disagreed with that.
When you're building that in AutoCAD, it doesn't burn.
No, not at all. Yeah, we see a lot of stuff like that. The wood industry is a marvel of picking and choosing what they're talking about. And one of the things they talk about, when you look at wood itself, and you're looking at the embodied carbon in a wood design, in a CLT project, a cross laminated timber project, or a mass timber project, as they like to call it. Some of the things they don't tell you, and to me, the biggest thing they don't tell you is about the harvesting of wood. Mm-hmm. So in their designs, they're always taking the most optimal numbers they can produce. So when they're looking at wood, and the reality of the situation is, if you look at wood, it might have really good embodied carbon, but it might have really, really bad embodied carbon. And the reason that you have this range, it starts at the very basic. Is your wood coming from a sustainably managed forest? Well, they always assume it is, but the truth of the matter is only about 14% of the wood in the United States comes from sustainably managed forests. And then the question becomes, if you think about the biomass of a tree that you're harvesting, how much of that biomass is actually harvested? And it turns out the answer is around 40 to 60%. So to start with, your entire root structure gets left behind. But all those small branches, and if you do manage to capture 60%, your embodied carbon is going to be a lot better than if you're only capturing 40%. And that's where part of that range comes from. But then you also have to look at what type of tree was it, because every tree, every breed of tree has a different embodied carbon content. You have to look at the age of the tree. You have to look at what the rainfall was during the growing seasons, if you're really going to calculate what the embodied carbon of any tree is. Then you run into a bigger problem. What do you do at the end of life? I mentioned earlier that steel is 100% recyclable. And when we have an old steel building, we're going to take that old steel and we're going to send it back to the steel mill and make new steel. What do you do with an old wood building? Now, if you have an old barn, if you have a 100-year-old barn, that's gold. The wood in a 100-year-old barn, those old timbers, people will pay a fortune for it. If you have a building that's a CLT, a mass timber building, that wood's not worth anything, because all you can do with it is you can either landfill it, and when you landfill it, what happens? All the carbon gets released in the atmosphere. Mm-hmm. Or you can burn it, you can incinerate it. Now, when you incinerate it, you're going to capture some waste heat, but you're still releasing all the carbon back. Mm-hmm. And that's one of the things that people don't talk about a lot when they talk about the sustainable aspects of wood. And it's frankly worrying to people that they're playing games like that. And if you look at the Carbon Leadership Forums, which is one of the serious sustainability people out there, they'll no longer accept industry-wide carbon data from the wood industry, because there's something called an EPD. It's an environmental product declaration. And every industry has them as industry-wide, and then manufacturers have specific EPDs. The Carbon Leadership Forum will no longer accept the wood industry's industry-wide standards because the range is too broad.
Makes sense. It seems very complicated. I would think that's very labor intensive to be able to calculate this.
There are specialty companies and there's specialty software, and then there are software that gives you a shortcut. So if you're using like an E3 calculator, that'll give you a shortcut to doing your carbon your life cycle assessments. And they're good as far as they go, but remember, you're also dealing with a black box, right? You don't know what their inputs are. So that's one of the things you have to be careful about.
Well, it seems like they're taking a shortcut on the initial side, the potential cost savings by going this route. But the argument is we're greener, we're sustainable, we're this, we're that, we're blah blah blah. But at the end of its life cycle, they're completely hypocritical, and they never address the end of life portion of what they're talking about.
Mm-hmm.
Well, I find it interesting, Sean, like you and I being in the Pacific Northwest, where we really value our forests and our trees, that we should be supporting. I remember back in the 90s, clear cutting was something we frowned against, frowned upon. We didn't want to be cutting down trees. But now we're looking at mass timber. And like you said, Scott, what was it, 14% of all forests are
sustainably managed.
Sustainable? Mm-hmm. Yeah. So I wouldn't. It seems counterintuitive that the PNW is really like looking for mass timber build.
Well, so you're both a little bit young, but
thank you, Scott.
Thank you. I was going to say the same thing. My daughter would tell you otherwise.
You remember all the commercials? Got milk?
Mm-hmm.
Yeah. And you remember the pork, the other white meat?
Yeah.
So what are both those? And remember that you also saw ones about wool. I don't remember if you saw the wool ones weren't as popular, but there were also wool campaigns.
Okay.
So what do you think all three of those products have in common?
Livestock.
Agriculture. Mm-hmm.
Yeah.
All three are agricultural products. And the U.S. Department of Agriculture has a program called a checkoff program. And what the checkoff program means is that every manufacturer in the country has to pay into a marketing program. So that Got Milk program was paid for out of a marketing fund, which was paid for by every single milk producer in the country. If you were a milk producer, you were required to pay into that fund, which was administered by the Milk Council or whatever, some milk council, supervised by the Department of Agriculture. So the Department of Agriculture wasn't telling them exactly what to do with the money. The Department of Agriculture was making sure they weren't, just spending it on, pontoon boats. They were spending it on legitimate purposes. And clearly, the Got Milk campaign was very successful. So if you're a milk producer, it was probably a good use of your funds. The wood industry has a checkoff program. So one of the reasons you see so much about wood is because there's a checkoff program and there's all those marketing dollars out there. And then it goes one step further. The U.S. Department of Agriculture is charged with promoting the use of agricultural products. Whether they're good or bad, their job is to promote the use of agricultural products. And wood is an agricultural product. And so the U.S. Department of Agriculture puts lots of money into research, into subsidies, into different programs to encourage the use of wood. So your actual tax dollars, Brandy, that your company pays helps to support the use of mass timber.
It also feels like a huge conflict of interest when you're talking about sustainability and you're promoting it for this goal that really isn't about the environment at all. That feels wrong.
It does. But you get a lot of evangelicists who really, really have drank the Kool-Aid and believe that that wood is the environmental, because intuitively, if you think about it, when you're talking about wood, we all like wood. I mean, I've never met anyone who doesn't like wood. It's beautiful. I have trees in my yard. They provide shade. I wouldn't move into a place where they've just cut down all the trees. It would be horrible. It would be barren.
Mm-hmm.
But it doesn't mean that they're the best material for necessarily building.
Right.
If you want an inexpensive, stick-built homes are inexpensive, which is why you see so many of them. They were really high quality when I was growing up, but the old growth forests are all long gone. There was 2 weeks in my life when I worked for a public relations company, and one of the things I worked on was steel studs for use in home building, and we were selling it as the Cadillac system, and it was fascinating because if you look at most houses that are built today, they're terrible. There's no square corners anymore. You have nail pops all the time. It's just awful. The quality of wood that you get you go to Home Depot, it's like, oh my God, I don't know if I want that in my house. But
I just went through that. I'm putting up a new fence. I had to get a number of fence boards. I think I went through 2 full units to get enough straight, decent material just to build one section of a fence. It was awful.
It's terrible stuff, which is why we were promoting light gauge metal homes, because all your corners are perfectly square. You're screwed in instead of nails. It's beautiful. It's more expensive, but it's
But the longevity is there too.
Mm-hmm. Termites are no issue it's a different type of steel. My AISC isn't involved with light gauge at all. But I'm always fascinated by that as a building system.
I'm not surprised. My brother actually would be one who buys into that. He's always talking to me about needing steel for his home. I'm like, why would you need steel beams for your home? I don't need to supply that to you. It's overkill.
Although most homes, at least where I live, we all have basements. So in a basement, a house with a basement, you always have one HSS column in the basement for support, and you always have a cross beam, and it's holding up most of your house.
So then it's important.
It turns out that Ace Hardware is one of the leading sellers of steel beams in the United States.
What, really?
Yeah, because if you think about it, what they do is they sell to home builders, and they're selling them as one-offs. Literally, they're selling them, one at a time. But think about how many homes are built, and they all have 1 or 2 beams holding up the superstructure.
Never crossed my mind.
Nope, I would never have guessed that. This is why we have you on, Scott. You're like a wealth of all these facts and this information.
It's just that I'm old and I've been around a long time.
So with this idea of the green steel movement, though, and all this talk about we've got to get there, we need to convert how we're milling our steel. Do you think then it's more of a marketing thing, or what do you think?
I think we need a marketing effort to let people know.
Yeah.
But the reality of the situation is the steel industry is making huge inroads. Nucor, which is the largest producer of structural steel in the United States, they just announced that they were revising their 2050 goals. They had goals of where they would be in 2030 and then even better in 2050. And they just revised them to be near zero by 2050 on scope 1, 2, and 3 emissions. And that's just amazing. And the difference is when Nucor is saying that, they can actually show you what they're doing to get there. So they're not just blowing smoke.
What are they doing?
So it's a whole range of things, starting with, I mentioned earlier, the 41% reduction we'll get when we go to 100% renewable energy. So they're working on sourcing their energy so it becomes 100% renewable. And that ranges from whether they build their own plants or whether they're just helping utilities build plants. To put that in perspective, and I shouldn't just say Nucor is doing this. If you look at Gerdau, do you know Gerdau?
Yeah.
So Gerdau, they have mills in for structural mills. They have structural mills in Virginia, and they have mills in Midlothian, Texas. I like saying Midlothian; it's a great word.
I've never even heard of Midlothian, Texas. So.
It's about 45 minutes from Dallas.
I've heard of Dallas, so that's great.
So in Midlothian, Texas, they just put in a giant solar field. I think it's something like 85 megawatts or something.
Oh.
So, think about how much electricity that's providing, and what that does to reduce their carbon footprint. And all the mills are doing things like that. Nucor is also looking at ways to reduce their use of natural gas. So if you go to Nucor's website, they have pages and pages of data about what they're doing. And SDI up in Indiana, they also have a lot of things. And if you look, they have their statements about where they expect to be in 2030 and where they expect to be in 2050, and they show their actual plan for how they're going to get there.
That's excellent.
Well, I was thinking, after the event that we sat through yesterday, I think that where Brandy was talking about the marketing of what these mills are doing, it would be more important now than ever, because what frightens me the most is the amount of money that they're talking about spending to do offshore wind, for instance. Some of the dollar figures I heard were alarming, and I mean, I can't even begin to explain what they were talking about and how much it would require infrastructure improvements. A single site would be $500 million, or they want to produce electric tugboats to pull these things out to sea 40 miles, or enough cable for one area of wind energy that the cable would wrap around the earth. And the whole foundation of their argument is one, to be green and renewable, but in order to produce this, they have to wait until the steel that they want to use to produce this is 100% renewable as well. And the fact that we've been there, and we are there, and that we've been there for what you're saying 20, 30 years, and that they don't know that, I have less faith in their argument. And two, I think that they are not as educated on the subject as they think they are.
So some of it's legitimate, because some of their a lot of what they're using is heavy plate and sheet steel. And if you remember, I said 70% of the U.S. market is
Beam too.
And so some of their steel falls into that 30%. But they also, for the wind industry and the geothermal industry and some of those industries, a lot of that steel is being produced overseas.
Most of it.
If you look at China produces, I can't remember the number, but it's astronomical compared to how much steel we produce. And they're not producing it in a necessarily sustainable way. And so that's where the disconnect comes. For what you do, you're tied into the building industry. And in the building industry, we're producing all that steel domestically. It's the other industries that aren't, and that's what we have to work on. The other thing is when you're looking at those astronomical numbers in the cost of power generation, they play in a different world than we do. And when they talk about a $500 million project, that's not an unusual energy project. If you think about some of the infrastructure needs we need in the United States, one of the biggest things we have is our electrical grid is falling apart because we didn't maintain it for the last 30, 40 years. And
the bulk of that is transmission related, right? Like they have They have sufficient power. They just don't have the means to get it where it needs to go.
Correct. And so that's a lot of what some of these people are working on, and the amount of money required is huge. And again, they're playing in a different box than we are.
Sure. It's hard to understand. After our conference yesterday, I came home and did some additional research, only because I'm curious, and
Sure.
if there's an opportunity for us to jump into that market, then so be it. But the story I was reading said until very recently that most of the blades have a shelf life or a use life of about 10 years, so around about a decade. And here in the Northwest, there's wind farms up and down the Columbia River Gorge, which is there's thousands and thousands of these things, and they're installing new and decommissioning old. And the story was that these blades would get taken down and shipped back to the Midwest somewhere and buried. And until recently, they've decided that they can chop them up, grind them up, and then burn them for fuel to produce concrete. And so that was the story I was reading last night. And then speaking with another gentleman at the conference, he's saying that they're producing, and he couldn't tell me specifically what material they were using because I was curious. But he said that the life cycle of the new blades that they're producing is 20 to 30 years.
Right.
But again, he didn't have any information on what kind of material they're using, where they're being produced, and if that's actual reality or not. But I'm curious.
I've read those same studies, and they seem to be heading that way.
I mean, I hope that they find something, but I mean, it's troubling now that they're either just burying it or they're grinding them up to just burn them to produce concrete, which is the other thing we despise.
Well, that's very true. Well, and then just burning them too, or burying them isn't good for the environment anyways. And so if we're being very intentional about even the tugboats can't be using diesel, that they have to be on battery life so that the whole process is sustainable and it's not producing emissions or damaging the environment, then why are we burying the blades? Like we've got to sort that out. Right. That's a flaw.
And that's, again, the single most recycled material by weight in the world is structural steel, is steel. And when you just look at that, so if you have a building right now and your building is typically going to be made out of one of three materials. Let's just say you have a 3-story building and it's either going to be made out of, wood, whether it's stick built or mass timber. It could be a concrete or some sort of masonry building, or it could be steel, right? You really only, you'll find an occasional building that used hay bales, but okay, that's a little esoteric even for me.
We are in the Northwest. There's some strange things happening out here.
But generally, it's going to be one of those three. And at some point, that building's going to reach its end of life. Do you know what the end of life for a soccer stadium is? What the average lifespan?
No clue.
30 years.
That's
and
like
what's the driver? Is that because of the concrete?
No, that would be good though. The reason it's 30 years is obsolescence as far as design and use. So it turns out that soccer stadiums get replaced especially in the United States. So it's about 30 years.
Wow.
So most buildings have a longer lifespan, but you see retail buildings coming down a lot. So if you have one of those buildings and it's reached end of life, you're going to call a demolition contractor and you want to have it taken down, right? So if you have a wood building and they want to you hire someone to take it down, they're going to charge you. And again, these are general numbers and it depends where in the country you are, how big the building is. There's a lot of factors, but you're probably going to pay somewhere in the neighborhoods of about $4 a square foot to take down a wood building. And the reason is they take down a wood building, they have to dispose of the wood. It's really disposal is what's driving that cost. When you take, and as I mentioned earlier, you take down a wood building, you only have two choices, right? You're going to landfill it or burn it. Both of them are very costly. So let's say you have a slightly better building. It's a concrete building. And you want to take that one down. They're only going to charge you about $1.50. Even though it's harder to demolish a concrete building than it is a wood building, concrete actually has some low, but some value in that you can grind it up, use it as fill, you can use it as aggregate. So there is a value. It's called downcycling. So you take the original use of the product and use it for a lower use, but you can get some use out of it. You might use it for road bed, for example. So they'll charge you about $1.50. If you had that steel building, that really high quality building, and you take it down, which I'm not sure why you need to take on a steel building, right?
Sure.
When you take down a steel building, they'll pay you to take it down.
Oh, wow.
And the reason they'll
That's
pay
cool.
you is because they want to take all that steel and sell it to a steel mill who'll pay a lot of money for that scrap, because they're just going to recycle it 100%. Steel can be recycled over and over again with no loss of material properties. And so that's an important little factor for an owner to think about.
But I don't know about Chicago, but out here, steel scrap varies between 8 and 15 cents a pound. So I mean that's quite valuable, even in the teardown. It's still a valuable resource.
And that's why they'll pay you for your building.
Sure.
So some of those things that you think about in terms of sustainability has to do with end of life. But if you talk to sustainability people, the people who are really diehard sustainability people, and this is horrible for the two of you to hear, but the diehard sustainability people say that the most sustainable building is the one you don't build. And the reason they like that is they can take an old building
And improve it.
Adaptive reuse of a building. And
Sure.
the easiest building to do adaptive reuse on is a steel building. And that's good for the couple things. In steel buildings, we have longer spans, so you have less columns to deal with when you're doing your adaptive reuse. But the other thing is, depending on the type of construction you're dealing with with wood or concrete, you can't just make floor opening. Oh, I want to put a staircase in. Putting a staircase through a concrete slab floor is not a pretty thing to do. In steel buildings, we can just reinforce that opening and we can just keep moving. When you're talking about a metal deck with concrete topping.
Adaptable.
Very adaptable. And so that you see that a lot in buildings, where you see retail buildings becoming office buildings. We gave an award this year to the Moynihan Train Center. It's an adaptive reuse of, I think it was, I can't remember what it was, but now it's a part of a train station. And it's a beautiful building. An old building got to be saved and repurposed. And you see that all over the place with steel structures. It's one of the beauties of steel.
I think we're fortunate too. Half of our market here is probably, I mean, we call it just tenant improvement, but it is those buildings that are getting rehabbed. I think that, especially in the Northwest, there's a lot of seismic upgrading. The buildings that were built in the past, they didn't necessarily have the current seismic requirements. So if somebody wants to do a rehab, that's part of the new standard, which is where we fit in. And I think that's one of our niche markets too, is the seismic upgrades for the big one, which hopefully never happens.
Yeah, seismic is a big thing with steel. In fact, seismic got me my job at AISC.
Really?
Oh,
How
really?
so?
So I had been working for a publisher, and I one day I quit. He had a bit of a drinking problem, and I just couldn't take it anymore. So I quit.
As I just put down my bourbon.
Yeah.
We take another drink to that. Sorry.
You seem a
Logs off.
little more functional than Dave did.
I'm just it's early.
So I was 29 years old, and I thought, oh, I should probably get a job. And back then, I'm looking through the newspaper, the help wanted, because we didn't have the internet. And there was a job for an editor of Modern Steel Construction magazine. And I was actually a construction editor. I mostly wrote about concrete, but I've seen the light since then. So I went to apply, and it didn't go well. The interview did not go well. They were not hiring me. The vice president who was interviewing me took an immediate dislike to me. But as a courtesy, he introduced me to the president of the company. And I was talking to him, and he's a big guy. And you're both too young to remember Loma Prieta, but it was a big earthquake in California. Do you remember the World Series between Oakland and San Francisco?
Mm-hmm.
And there was an earthquake?
Oh, yeah.
Oh, yeah, of course, specifically.
Loma Prieta.
I didn't know it had a fancy name, but
Yeah.
And
you could have led with that. We would have been like, oh, yeah.
Loma Prieta is where the epicenter was of it.
Gotcha.
Okay, so they had this earthquake, and I happened to be interviewing right after that, and I was talking to the president. I said, I was just over at Portland Cement Association headquarters. They had a press conference. We were talking to them, and according to them, all the problem with all the structures that failed were because of steel. And he's turning red in the face, and I was thinking, okay, if he had a gun, I would probably be dead right now. And I paused just long enough and said, yeah, they said there wasn't enough steel in some of those structures. And he had the exact reaction you just had, Brandy, and turned to the other guy and said, okay, hire him. And that's how I got hired at AISC.
That's awesome. He's like, deal. Come on. I don't care where you're at.
That's fantastic.
I agree. I think this is a marketing issue, and I think it's in our best interest that we get the word out that green steel already exists, that we are recyclable, we are sustainable.
Mm-hmm.
Scott, what if any, is there any plans with AISC on spreading this message?
We do. We spend a lot of time talking to. So one of the things that we do at AISC, in addition to, I'll go out and I'll talk to the trade press. We'll talk to people. We try to talk to people every time we see an article talking about the myths of wood that they're spreading. We dutifully contact that editor who wrote it, and they dutifully listen to us and ignore us. And one of the things that we do at AISC, because it's not like we have 10,000 employees. Mm-hmm. Our marketing communications department has 3 or 4 people in it, and there's a limit to how much we can really do with that small group. But what we do is we strongly believe in industry mobilization. We believe in messaging, and we believe that people like you two are really the army that can spread the word. So what we do is we produce for our industry common messaging points. And we try to spread those common messaging points so that companies like Nucor, who have thousands of employees, service centers have lots and lots of salespeople. There are 1,000 fabricator members of the Institute who all are talking to people out in the world. And they're talking to people who are both engineers, and they're talking to architects, they're talking to building owners, but it goes a little bit beyond that. And there's a guy named Gary Stein. Gary Stein is the president of Triple S Steel. They're one of the largest service centers in the U.S. And Gary's actually like super smart. You wouldn't know it from first meeting him, but it turns out Gary's like a genius. And I'll sometimes call him with really obscure questions. And he'll say, yes, I was over in England and we encountered this person who did this, and that's why. I'm like, how do you even know some of this stuff? The guy's just a genius. But one of the things he talks about is he'll say, yeah, my dentist brother-in-law said blah, blah, blah. And I'm never going to reach Gary Stein's dentist's brother-in-law. The odds of my meeting him and talking to him about sustainability is really slim. But if Gary has the same messaging points and he talks to his dentist brother-in-law, that's a horse of a different color. And that becomes a really powerful tool for the industry if we're all using the same messaging points, if we all understand the sustainable aspects of steel, and we're all talking about it. I'm probably a terrible person at parties, because I'll be at a party and I'll start talking about, oh, do you know what the recycled content of a steel member is? That beam, do you know how much recycled content that beam has? And people are like, oh, 30%. And I'm like, no, it's 93. I'm like, really? That's blowing my mind. Now can we actually go back to our party? But I honestly believe that everyone should be spreading that message, because there's so many falsehoods out there, and it's only going to be beaten if you're telling your friends, and Sean's telling his friends, and I'm telling my friends.
Word of mouth.
Mm-hmm.
For our listeners, Scott, do you guys have any resources at AISC that we could have them look?
Yes.
So they can help spread that message.
So AISC's website is AISC, Apple Isaac Sam Cotton, or American Institute of Steel Construction, or these letters.
Other side.
There we go.
There you go.
It's a reverse camera thing. So AISC.
I was gonna say it must be a new shirt.
It's Friday.
.org, so AISC.org. And one of the difficulties with AISC.org is, again, we're a technical institute, and we, on our website, we have between 10 and 20,000 pages of material, and it's a little bit overwhelming to try to find something. So I always tell people to cheat. I tell them to use shortcuts. And what we typically do is AISC.org/ and if you think about any topic and try putting that word in, the odds are you're going to get to where you're going. So in this case, if you do AISC.org/sustainability, you'll get to reams and reams of data about sustainability.
Oh, that's awesome. Yeah, I think you can get lost on that website.
Mm-hmm.
If you're not careful.
We are working on making it better, and we're actually working on some artificial intelligence engines that will help in so you can go to the website and tell the website what you're looking for in normal language. But that's not going to happen next week.
No. That's incredible. That's a great advancement. That's a good opportunity.
I think everyone's moving towards that. We're not unique in that. I think in a couple of years, you're going to see that at everywhere you go, where we're just using it. And if you go to, even if you go to ChatGPT and ask it, is steel sustainable, it'll actually reference us.
Excellent. Really, I'm going to give that a shot too.
I hope it references. It does when I do it. Anyway.
It might know you.
Outside this particular topic, AISC also has a ton of training material for steel fabricators and mm-hmm. people that do what we do, and it's a great resource for not only your management but your sure. workforce as well. So there's some huge advantages to being a member and or just knowing the website, because you don't have to be a member to get the resources.
Well, one of the things that we offer is the Steel Solutions Center. And if you call 866-ASK-AISC, or if you email solutions@AISC.org, a real person, if you call, a real person will answer the phone. And they're a really bright structural engineer. You'll often reach Yasmin, for example, and you can ask her a question. Now, we hope you're calling to ask questions about structural steel, about the spec, and about design. And they answer hundreds of questions a week. It's a free service we offer to the whole industry. We're hoping people don't do what I did when my kids reached a point where I had trouble helping with math. I told them, just call the Solution Center. That's not what it's designed for.
That's a huge resource, Scott. Thanks for sharing that.
Mm-hmm. We're working on a lot of workforce development activities. So, one of the things that when my kids were in school, it was the really big thing was no child left behind. Mm-hmm. And the idea was every child should go to college. And when you think about that, that's not great advice. Because a lot of kids come out of college, they have liberal arts degrees, they don't really know what they want to do. They don't know what type of job to get. They don't end up with great jobs. And then you look at like your company, which I'm sure right now, if a young person who was anxious to actually do some work came in, you'd probably hire them. You probably have openings right now.
Yep.
And so our workforce development has two things that we're working on. One is just letting people know about the career opportunities in structural steel, and there's huge opportunities, and they're good paying opportunities too.
Absolutely. I think it's a marketing thing. I think, back in, like you said, when your kids were growing up, we leaned too far in one direction, getting
Right.
everybody to go to college, right? And in the process, I think that we shamed the construction industry and the trades,
Right.
like it wasn't an honorable job or it didn't pay well. And now we're suffering, and our society is going to suffer if we don't get people back in the trades. And it does pay well. And it is honorable. You are literally creating lasting legacies and buildings that will outlast you, likely. You come down to Portland, Oregon, those buildings have been there since the early 1900s.
I get out with iron workers, and it's so exciting when they look when you're standing there and they go, "Oh, I built that."
Exactly.
And that is
I built that.
Amazing.
We actually use that as a slogan for, and I should go upstairs and get a T-shirt and show you. We have it on T-shirts that we give to kids. I built that. And then
built that. Does it have like a finger pointing like that? I do that to my kid all the time.
You have to provide your own finger.
That's so awesome.
But we also are developing training programs, and the training programs are for people like you to use. So when you hire someone and they don't know anything, they don't have the skill set you need, they're not a replacement for what you're doing in your shop. They're an aid to help speed the process. So these training programs deal with things like fit up, they deal with welding, all the entry level stuff that we're doing in fab shops, and these programs will be starting to become available early next year.
That's excellent.
Fantastic.
We actually are going to be starting to speak at high schools about this exact topic. It's something that's very near and dear to me, and I love your slogan T-shirt idea. I built that. I have a husband he's in a totally different trade, and every time we drive by any project he's ever worked on, he tells us, and we're like, "Yes, we know, we saw it coming. We don't need to hear that you worked on that project."
and if you need help with anything, we have a dedicated person named Jenny Trout-Tradero, brilliant young woman. Actually, I shouldn't say this. She's a very driven person. So, she has a program. She's going to drive that program to completion, and it's just wonderful to watch. And I love when we see these young people who are anxious to succeed, and what she's working on is exactly what you're talking about, helping you when you're going to go to a high school connect. How do you connect with those students?
I'm definitely going to reach out to her. Yeah. Well, thank you, Scott. I really appreciate you sharing your expertise and your insights today. I think it's really valuable, and I'm excited that our listeners can glean your wisdom from our podcast tonight.
I hope they get something, but always happy to talk to anyone who wants to talk about steel.
Wonderful.
Sure.
Well, thank you, Scott.
It was a pleasure. We look forward to seeing you at the AISC conference and
March
San Antonio this year.
San Antonio.
We will be there, eager to learn some more. And we appreciate your time, Scott.
My pleasure.
Thanks for
We'll see you there.
All right. Thank you.
You're welcome.
All right, let's go ahead and get started. 1, 2, 3. Nope, I'm gonna start over.
And the production of coke and not the good coke. We're talking about the coke we use in steel making.
Although it looks the same, doesn't it look the same though?
Well, maybe. I'm not saying. And you don't want to mix them up. I'm telling you that.
I'm sure.
So you're both a little bit young, but
thank you, Scott.
Thank you. I was gonna say the same thing. My daughter would tell you otherwise.
D6 design guides, the former
Wave Energy, right? And
thing is, they're waiting for this green steel
what the embodied carbon of any tree is.
That really isn't about the environment at all.
One of the things I worked on 2050, and they just revised them, the single most recycled material by weight in the world.
Varies between 8 and 15 cents a pound.
I'd been working for a publisher, and I one day I quit. He had a bit of a drinking problem, and I just couldn't take it anymore. So I quit.
As I just put down my bourbon.
Yeah.
We take another drink to that. Sorry.
You seem a little more functional than Dave did.
I'm just it's early.